There is one big philosophy of modern cryptanalysis, and it's done by Kirchhoff's principle. It's called like that, and it says the security of a crypto system must not depend on keeping secret the crypto algorithm. Rather, the security depends only on keeping secret the key. So which means no matter how you make your algorithm and how difficult to make it or the whole system is, eventually it's going to be breakable. So rather, we want to keep just a secret the key, whatever the key is. It's a number or word, whatever it is, right? So in the history, there are many evidence that people eventually figure out the algorithm. So no matter how you make it difficult, it's still breakable. Okay, that's the whole issues here. Okay. And one of the main reason for that is we really haven't seen that parts in monoalphabetic case. No matter how you make it, you can still break it. And one of the main reason is because of the frequencies of letters in plain text. And these are the frequencies for each letters in English. And E, the letter E, has more than 12% frequencies in any literature. And A has 8 point something, and HI, each of them is greater than 6, and NO also has greater than 6 or 7, S and T is greater than 9, like that. So if you group these letters in certain way, then any letter appears more than 12% is E, and any letter appears more than 6 to 12, or usually it's between 6 and 9, is these letters, and all together as a one group, it actually appears more than 50% of the whole literature. So technically, if you know what letters is assigned to these letters in plain text, then all together we can almost figure out 70% of the whole plain text. Then a lot of times that's enough. So we don't need to figure out all 26 letters like this. All we need is just few of them like this. So in this second group we have total 8 letters. So including E, if you figure out just 9 letters in ciphertext, then that's enough to figure out the whole message. And there is something more even. To figure out these letters, these are the other kind of information. These are the frequencies for 2-letter words. And TH, okay, if you have a 2000 letters message, then TH appears 50 times in average, and ER appears 40 times, and ON appears 39. So if you have this kind of list, then no matter how crazy the ciphertext look like, you just matching any 2-letter word in the ciphertext and matching with this TH or EL, and try to see it, whether it's really matching with other remaining parts of the ciphertext. And eventually you could get some results out of it. And even more than that, these are the kind of common trigraphs. Okay, so 3-letter words, and THE happens number 1, A and D happens second time many, and like that. So just try to put about this much or that much, then it's enough to figure out what letters are assigned to what. So if you combine these, all these kind of 4 lists together, then no matter how they make that ciphertext, actually you can figure out the plain text if it's done by monoalphabetic. So that's the kind of weakness of this monoalphabetic cipher.